these, they look a little bit different. In particular, if you notice right here, instead of just x, it's got this x plus 1 up there. Same thing still. This and this have to have the same base. So they both need to have 8. We just got to figure out what number goes right there. So again, looking back at our handy dandy little table here, I need to erase this. It's getting messy. There we go. A little bit better. Sure, so tiny. Okay, so we're looking in the 8, and I'm looking for 64. So 8 to the second power equals 64. So 8 to the second equals 64. Right. Now they have the same base. They both have 8 there, which means we can take these powers and say that they are also the same, or we say that they are equal. Now that's just a straightforward linear equation. You've seen 1,000 of them, or maybe a couple hundred. I don't know how many. I've seen millions of them, right? Get rid of that. You finish solving and you end up with x equals 1. So it doesn't matter what's up in that power. The process is still the same. We just have to make a match. Okay, let's try this one. We've got 9 to something equals, now can I turn 6561 into 9 to the power? Well, let's go back to our handy dandy table. Looking in the 9's column, looks like it's to the 4th power. Right, so 9 to the 4th power. Right, bases are the same. Right, we've got a 9 and a 9, so I can take my 2 powers and say that those are also equal to each other. And then you finish solving, nice and easy. Divide by 2, divide by 2. You got to divide, right, because it's 2 times x, which leaves us with an answer of x equals 2. All right, so everything we just did, this is the process. You need to rewrite it so that the bases match. That's the key there, is getting the bases to match. So if it's got a 5 on one side, it should have a 5 on the other, or something that matches. Then the next step is to set the powers equal to each other, and then solve. Set the powers equal and solve. So this first example here, 5 to something equals 5 to something. So those two quote-unquote somethings can now be set equal to each other, which forms an equation, a nice simple equation that you would solve from there. Okay, these ones I would probably, I don't know, add the 3 to both sides first, so that then I have, let's see, x equals 4x plus 9, and then subtract the 4x over. This is linear equations. Hopefully they come to your mind. The idea is to get the x's all by themselves. So over here I've got negative 3x equals 9. Now to finish that, because it's negative 3 times x, the only way to get rid of that 3 is to divide by negative 3. Gives me a final answer of x equals negative 3. So when it says to solve an exponential equation, this is the first thing that you're going to look for, is can I get those bases to match, or do they already? Okay, here's this next one right here. I've got 100 and I've got 10. So this is the one I'm going to change. I'm going to say 10 to what power? That's 10 to the 2 equals 10 to the negative x plus 10. Now, just like the previous page, That's all we did, is I made these guys match so that then I can take the powers and form their own equation. 2 equals negative x plus 10. Now in order to solve that, I would subtract the 10 from both sides. Whoops, not divide, gosh. You might say to add the x over. Either one's fine. You end up with the same answer either way. So here I get negative 8 equals negative x. I prefer to have my x on the left side, so I'm going to rewrite it as negative x equals negative 8. Now, I don't know what kind of tricks you were taught to deal with this, but technically that's a negative 1. So I'm going to divide by negative 1. You have to do that because x has got to be positive. So x equals negative 8 divided by negative 1 is positive 8. So solving exponential equations using powers. This is what you're going to do. And you're going to have that handy-dandy little table with you, and you can use it through all the problems. The point is that you're able to solve these equations using that. So let's start with this one. 65536 under the 4 column. Let's see, that's this guy. So 4 to the 8th. That means that x equals 8. Okay, 2 to the x minus 2 equals 8, which is 2 to the 3rd. You can look back at your table if you need to, which says x minus 2 and 3 are equal to each other. So plus 2, that means x equals 5. This one says 5 to the 3x, and over here we've got 15625. So let's look back at that table. 5 column, 15625, that's a 6. So this is going to be 5 to the 6th equals 5 to the 3x. That means we can take the powers, now that these match. 6 equals 3 to the x. Again, I prefer my variables on the left, so I'm going to flip-flop that. Divide by the 3 to get rid of it. That means x equals 2. All right, this one, oh, the bases already match, right? Which means 3x minus 2 equals, wait a minute, there's no number written there. When there's no power written, we assume it to be a 1. So we can now say that 3x minus 2 equals 1. Okay, I'm just going to finish solving, get rid of the number parts. 3x equals 3. Last step would be to divide by that 3 over there to get rid of it, which ends up giving us that x equals 1. If I went through these too fast, you can rewind and pause and look at them again. I'm just trying to get through a few more examples for you. All right, let's solve these equations. Okay, a little bit different this time. We've got 3 to the x minus 2, but look, we've got 9, and 9 has a power on it. So 9 is going to be 3 to some power, right? And then you're going to apply this x afterwards. So let's start with the 9. 9 is the same thing as 3 squared. Right, so we've got this side, and then we've got this x, and he's hanging outside, right? He's not a 9 anymore. It's 3 to the 2nd power, 3 to the 2, and then there's an x power outside. Now, how you deal with that, when you've got these two powers here, the exponent rule says multiply those guys. Okay, so now we've got the same bases. So we can take our powers and make an equation out of them. X minus 2 equals 2x. Subtract that x, move them over here. Negative 2 equals x. I like x on the left. So I'm going to write like that. Now, one more time. There were properties back when we were reviewing properties of exponents that said if you had something raised to a power and you raised it to another power, that you could multiply those powers together. So that's what I did right here. I had 3 squared, and I raised it to another power. So I keep the base, and I multiply those 2 powers together, and that becomes my new base, right? So that right here is what happened here. Let's try another one. Okay, we've got a base of 8 and one of 64. Now, obviously, I can't turn 64 into 8, but I can look at my handy-dandy little table over there. On the previous one, it says that 64 is actually 8 squared. All right, but that guy's got an x on the outside, and that equals 8 to this power. All right, now learning from what we did over here on the right side, that means this is 8 to the 2x with 8 to the 3x plus 1. This is dragging a lot. I even have my glove on to prevent the dragging. Made a little mess. Give me a sec. Okay, bases match now. Both are 8, which means 2x equals 3x plus 1. Looks like a 7, but it's really not. Let's go with minusing the 3x. It doesn't matter which side you move the x's to. It's just my preference to go x's on the left. So negative x equals 1. It's this guy, right? And we said if we divide by negative 1, that gets rid of the negative in front of the variable. So x equals negative 1. All right, last one. 49. Oh, 49's not on our table, right? I don't have 49 to a list. Oh, but wait a minute. Look right here. 49 is actually 7 squared. So can that help us? Well, let's rewrite him as 7 squared. And then he's got that x power up there, right? And how does that help us? Well, if that equals this guy, can I write 2,401 as 7 to a power? Let's look at our little handy-dandy table here. Looks like 7 to the 4th is 2,401. Right? So this is 7 to the 4th. And that's being raised to the x minus 1 power. Okay, the rule over here says if you have something being raised to a power, then you just multiply those powers together. This right side, it's 4 times this whole thing. So I'm going to put it in parentheses. Okay, same bases. So I can set these two things equal to each other. 2x equals 4 parentheses x minus 1. Now if you remember to solve this, 2x equals 4x minus 4. Okay, going to get those x's over to the other side. That gives me, going over here, 2x equals negative 4. Last step to get x all by itself is to divide by 2. And my final answer for this one is x equals negative 2. So there might be more than one thing that needs to be substituted in for. Just look at that table and see what you can find. And then the solving is where the most practice is going to be.